or
yeah. So we're for my mother's 70th birthday, we give her a trip to Morocco, and after a few iterations, it actually ended up in Germany, in Bayern. Long story, but the logistics was 8 people, 5 adults, 3 kids. We're talking finding the hotels, booking them, booking flights, booking transport, and so on. And I've tried a bunch of these things in the past with OpenAI's operator. Even the Claude has a Chrome plugin,
right?
And it's been failing. But actually, they've passed a usability threshold. And this time I used OpenAI Atlas. That's their new browser. Essentially very similar to Chrome, but has a really good integration with.
But isn't the difference that it is a new browser instead of browser use, right? So it's built in from the start in some way?
Yeah, right? Exactly. So, and the model, the agent model that they're using is, well, it's solid. It's not fast. Like in many cases, you could do things quicker yourself. So it's not like it's not a good research tool in terms of like, oh, I want to, but for doing things like getting information. So I use various tools to source the hotels, and then sort of when we had the choice, it could reserve the rooms, fill out all of the information there. So for me, it was just to check and.
So just to be clear, so you source the hotels, you got a favorite one, but then you could just tell Atlas to please book a room here.
Yeah, exactly. And since I did a lot of the conversation before in ChatGPT, it had already everything in memory, so it knew how many people and so on.
So you had a tab in Atlas where you chatted with ChatGPT?
Exactly.
Okay.
So you get like a sidebar where you can instruct it. And yeah, it does struggle sort of when you observe it. It does struggle with some fairly basic things on selecting things from drop-down lists and navigating pages, but it's persistent. So in the end, it succeeds.
Oh, cool.
So you can.
I think this is such a great example how AI can be really good at some things, which is like managing a large amount of data, but so bad at other things that human really have a very easy time to do, which is to operate like a user interface, like a browser interface. But it's hard for AI to do it.
In this case, I mean, everything that has to do with images is hard because the way that we represent images to it is we're really compressing them.
Do you think it's still like screenshot kind of interface?
Yeah, absolutely. So, and it's still clip embeddings based, and you sort of lose spatial information.
Yeah.
And then they fine-tune them on UI interactions, but it's still like it doesn't have good vision. Let's put it that way.
But I love to speak about what people I think sometimes confuse AI and think it's good for everything. But there are many things that AI is really really bad at, and simply being able to operate a user interface for humans is something that AI is really bad at.
Yeah, but rapidly getting better.
Yes,
and There was I had another example, this was at work. There is a standardized thing that we have to do every few years, like a health and safety course, and I thought this would be interesting to try it out. To can it get through one of these tasks?
So you don't have to do it yourself, you mean? Or?
And it was more of an academic exercise.
Okay, of course.
That's how it was the academic exercise.
Exactly. But it's like for me as a human, and I clocked this because I did it myself, and I let it, like it took roughly the same time, but it actually completed it, and it was like 30 minutes, and it did it autonomously, and got 100% right on the test.
Zero shot in that case.
Zero shot, yes. And it was super interesting then to watch also. because when it's information pages, and this is the interface is like you have a bit of information, and then you click next, get a bit more information, and then there's like a quiz or a question, and so on. Then there's a test in the end, and then you sort of it just blows past the information. It's like page, and then it gets to one of the tests where it has to like you have to click on 3 things, and there it like spends 5 minutes. Like, I'm gonna try to click here. No, that didn't work. What if I click here? Like that's really trouble navigating that.
They have this funny name, Maravoc's paradox, I think it's called. Where things that is easy for humans is really hard for AI and vice versa.
Yeah.
And in this case, I mean, what you said, I think is really true. I mean, just reading through a large piece of information is super fast, but then the selecting things is really hard.
It's sensory input. It's not a question of intelligence in this case. It's sensory input. It's just like it gets such a bad representation of.
So it could be fixed if it just had better sensory input.
But just in practice, when you did the booking, what was the practical way you did it? Like set it up in the evening and let it, I mean, like you said, it wasn't fast, so then let it go and do its work, and then you checked it?
The hotel booking was rather fast. That was like on order 10, 15 minutes or something, and I did other things. But what I thought, like sort of where it really clicked for me was around the travel. So booking the flights. Okay, that's no problem. But what I did was I sent like an email to my mother and my sister, and I asked like, okay, who's like everybody's? Can you give everybody's full names as they are in the passport and birth dates, like, or personal numbers? And they sent it over, and then it was like, yeah, you look up in Gmail. You have all the information you need there, and I use that for booking. And then it was like for transport, it was write an email to the concierge at the hotel for airport transfer. And like it did it really well.
Cool.
Almost really well, I should add, which is goes one again with this kind of LLMs being not having a common sense. Yeah. Basically, the concierge email, I had it actually written before. So it was when I did the hotel booking. So I asked it to write it there. And then when I got the flight information, I asked it like, okay, now insert the information from the flights. And it did so, but it was like outbound, Stockholm, blah, 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 inbound, like a lot of detail and completely unnecessary detail for the people at the receiving end. I mean, they don't need to know that we're flying from Stockholm at what time and from what airport. They only need to know that we'll be at Munich airport at this time. And sort of...
More common sense things.
Yeah, that kind of thing. Because then it was hyper-focusing on flights. And then it did that.
I mean, I think it's really cool. And you're speaking about, there are all limitations to what LLMs can do. And this is actually why we asked you to come here again, Luka, to speak specifically about the practical limitations of LLMs. So, and I must say, I think you are one of the most knowledgeable person I know in AI. So I'm really glad to have you here again. We also worked together when you were the founder and CEO of Peltarion, and then the VP of AI and Data at King as well. Sure. But now you have a new exciting title. Can you just describe a bit more? What is the current title you have?
Yes, I was going to say I'm principal engineer, but I'm not. I'm a distinguished engineer. That's the
higher level, right?
That's that. Yeah, that's the. If you think of you have sort of a management ladder in corporate world, where you have like manager, senior manager, director, senior director. It gets to VP level, and then it's sort of C level. This is the equivalent, but in the individual contributor part. So my last role was VP level, and this is the equivalent, but in the individual ladder.
C part, yeah.
And so what does King hasn't had distinguished engineers before, so in that context it's new, but Microsoft has. And King is part of Microsoft, and a lot of my stuff now is with Microsoft. Basically, distinguished engineers, and there's one level above, which is called fellow, which is sort of C-level equivalent. are individual contributors that are set out to both be sort of technological thought leaders in the company and sort of show the direction more hands-on than a CTO would be. Mm-hmm. Some companies have the equivalent title of field CTO.
Right.
So that's So it's there is a component to that, but it's also like you're an individual contributor with essentially a mandate, like go and do things that matter, like identify things that are sort of within your technological.
So a lot of latitude and freedom to choose what you want to work with and see how you can contribute that. Yeah, as an expert in AI. Yeah.
And the nice thing is, like, I'm still part of King leadership team, and obviously I have all of my network and all of my past experience, meaning that I have an easier time getting the right people to listen and getting something to happen than somebody who's just coming from purely the technical side and been on the sort of engineering side. So it's one of the theories that King CTO Eric Baumann has, that it is important to have these fairly senior people on the engineering side as well.
Right.
Yes.
Which I agree with. I think that it's...
And if you contrast that to the normal enterprise, I find sometimes they have a hard time capturing this career-wise. So you're doing the normal corporate ladder up to senior vice president, SVP or C-level. And in some ways you have the CIO then, who is really a manager and maybe sometimes very, very far removed from the technology. And then you might find very super senior expert people, but they get buried in the stack, so to speak. And then so we have a hard time balancing a strategy from all the aspects. And of course, in software, the engineering aspect is super important. But I think that's going to be more and more important with data and AI in any. So it's an interesting learning how we can...
I think also, like, speaking from just purely, if you're into an enterprise career, that it's good that there isn't like a dead stop there, that there should be an equivalent to...
But I remember the Peltorian days. I think we used the metaphor like a mountain, if I'm not mistaken, where we could climb the mountain in different paths.
Yeah.
Right, and it could be the managerial path, but it could also be the individual contributor or the engineering path.
Exactly.
And I think that's something that some companies miss.
More people should do it more carefully and to understand that, because I've seen how you, in some ways, you get to a ceiling and then you need to take on staff and go the leadership, general manager route. And that's not for everyone either.
No, and it does leave a gap in sort of seniority, because typically the CTO is, of course, there are different types of CTOs depending on the organization and so on, but very often that role you do have a lot of organizational responsibilities and so on, meaning that you don't have time for hands-on tech. And having that at a certain level and exploration there, I think it's important, and I think it's a good model. But the tech, all of the sort of classical big tech companies, Microsoft, Google, and so on, have these roles.
But perhaps not traditional enterprises.
No.
That's what I'm seeing. That's the lack. But I was curious, how do you do the chain of command? So do you have like a solid line now, and a dotted line into a fellow engineer, or how does it work?
No, it's my forward reporting line is to the King CTO.
And the other part is used the role, but it doesn't have a reporting line as such.
No, it is. And again, King is part of Microsoft, and there is like this larger community, and the distinguished role engineer is more of a sort of Microsoft. But you could say that.
And who is organizing, if you want to organize the distinguished engineers and call them together broadly, or how, do you ever do that? So you have a distinguished engineer meetup?
No,
Really.
at least not in Microsoft. It's more of like informal networks.
Yeah.
Like you know a few, and then they know a few, and then you sort of collaborate across. What's typical is that these on the Microsoft side is that they are super well connected.
Yeah.
So Microsoft has a tradition of really catering to that.
Interesting as hell.
Yeah.
Cool. But let's dig quickly into the topic of today and the practical limitations and I guess like bottlenecks in general for businesses to find value and scale value from AI. And I think you mentioned a term. Let's see if I can recall it correctly. It's critical intelligence threshold. Was it that? Or what was it?
Possibly. Sounds wise. So.
No, but okay.
No,
but
yeah.
what do you think the main, if you just start like that, what are the main practical limitations for companies to find value from LLM-based systems?
I think the biggest practical limitations is that the failure mode of LLMs and agents are vastly different from human failure modes.
Good.
So imagine you're doing say an analytics report or something. So you have the AI looking up things in databases and looking internal documentation and putting together this fantastic report. And what you get out is 90% accurate. And now this may be, I'm not saying it is, but it may be on parity with sort of human performance. Humans make mistakes as well.
Yeah.
But a human domain expert will make subtle errors, while the LLM can make like really, really basic errors in some areas and can be completely brilliant in others, and you can have it in the same report. And then comes a problem of like how we usually evaluate things. And when an domain expert gets an LLM generated report and they see this basic error, and they think like, if it can't even do this, how could it possibly know anything more advanced? Yeah. But it works differently. It's like it really can be really, really brilliant on one part and then a miss on another.
Right. I mean, it's the concept of the Moravec's paradox, I think it's called, where some things that is easy for humans to do is really hard for AI to do, and vice versa. So some things that AI does really easily is really hard for humans to do.
Yes.
And I guess this is what you're speaking a bit about. The failure modes are different. So.
Yes, exactly. And one thing is what this system completely lack is like a common, what we call common sense. So it's very often, and it's fun when you combine multiple AIs working together, multiple agents, multiple LLMs, is that they really tend to push each other and nerd down into hyper optimization of details. So you sort of you start off with something that's simple, and they just add layers of complexity of like, oh, how can we make this better? Right. I've had now one of the things that I've been not voluntarily but by necessity been focused on is optimizing some things for running on GPUs and training hardware and so on, where there's a lot of optimization of the algorithms involved. And typically, like you always, like I work, like all of the coding is done by AI with me supervising. But typically, I always have to sort of pull them out of the descent into detail, where you encounter a problem, something is not working, and then they try to solve it by increasing complexity instead of like decreasing. Like, no, we need to reduce this to the simple case, get that working, and then...
You mean like finding an alternative solution instead of just trying to create a patchwork of fixes?
Exactly.
Okay.
But it's also like, they're very interesting, the sort of emergent behavior and personalities, I'm doing air quotes here, that emerge, because these are still next token predictors at the core. They are modeling, they're trying to output the most likely thing that's coming from what you've been doing in the past. So if you've been discussing a specific solution, it's going to be biased towards going towards that. So what is more amazing to me that actually it can it can pull itself out of it.
I'm going to add to the list here, what should we do besides next token predictors? But let's keep that until later if we could.
Yeah.
Okay, but failure mode. Yeah.
But just as a way to set the theme now, because we started immediately with limitations, and we actually when we in the prep here we I think we did a very interesting framing, practical limitations for agentic business processes. So if you take a little bit like we have limitations in what they do wrong in terms of that. So if you now what's the implication of that? If we stay on the same problem, so to speak, but we look at it from the lens of we are trying to put something in production or in business. So how would you frame the business problem? You looked at the behavior of the LLMs and where the limitations are, and what does it mean from the business problem limitations?
So I think there are different dimensions to the sort of business aspect. One is the simple of like, okay, how do we work with this new technology with its opportunities and limitations? The other one is pure change management of like, how do we get people to really do this? And I think there's a very interesting bias, pro AI bias that's just across the whole tech industry and wider, because you have people who are in high up roles in the company and decision makers are, and this like applies to me as well, are essentially ex-technical people. They haven't been doing technology for a while, really hands-on stuff, and they get this tool, and suddenly they can do things.
I see what you mean.
And their perspective is one of like, wow, it's liberation. I got these superpowers now. It's so amazing. But if you look at from the perspective of software developers who really likes the craft, that experience may be different.
Right.
They see like, I have this thing that I love doing, and here's something that's doing it, but not in the sort of craftsmanship way.
So someone that's a super expert in TypeScript or something, and suddenly an AI comes in and says, "No, you should do it like that." And then they get annoyed, I guess.
Yeah, and that it makes errors, and sort of they have their process, they enjoy their process. It's like they do like the work of coding, the crafting bit. So it's. And I guess, I mean, even when I was coding myself, I was always motivated more with getting the results
than the
rather than
process.
the coding. So, but you are different there.
But I mean, you're still an expert coder, I would say. But I guess for some years you were more into management rather than coding, I guess. And
yeah, I mean. Until the GPT came along, I mean, apart from some just hobby coding and scripting, I hadn't coded for years.
Yeah. But okay, but do you think the more super techie people that is really into software development, then do you think that they will not appreciate AI as much, or do you think that's just another way for them to use AI?
So this goes across the board. I mean, development is just one thing. If you look at take art, image generation, video generation. I mean, from a production quality point of view, they're getting like really, really good.
Yeah.
And if you're an amateur or just a casual user or a consumer of it, and not a producer, not an artist. Like you're super happy with what you're getting. Yeah. Like, look, I can do get an image of anything that looks really good in any style and so on. But if you're the one who wants to have the creative control to produce and so on, you're not gonna get what you want from the tool because it doesn't have that precision level.
But still, if you think from a software engineering point of view, there are so many tasks that is super boring.
Yeah.
Like writing tests, perhaps, or doing the documentation, or understanding, if you have a super large code base and you can't really, as a human, get all into all the details of it.
I don't think that's controversial. I don't think there are very few who are rejecting AI outright now.
Yeah.
And that even the creative communities are like shifting in that perspective. We still haven't gotten to the Well, I guess we have in coding, which we're seeing with the sort of rapid development of things. But sort of what happens when you stack on top, like when you build the next level. For art, it's like, okay, what happens when a great artist gets this fantastic tool? But there is, it's a simplification.
But if I'm trying to extrapolate out what's the problem here, or how can we frame it succinctly, what you're saying is that one of the practical limitations when we're going to implement this in business is that we need to be very, very mindful of some sort of persona approach. So literally, how do I sell? How do I evangelize? How do I drive change management with a hardcore, proud coder and how he should be augmented and love AI versus the ones that are sort of, that has a completely different view on the whole thing because they're coming from the liberation point of view. This is super important to take as a persona strategy. Is that a fair summary?
Absolutely, and it's not easy because there isn't there isn't a solution that's going to make everyone happy. Because I mean the change is happening now. It's happened to some degree or to a large degree already. The role of the software developer is changing, and for what it was 10 years ago, 5 years ago, that role is not going to exist.
Right.
And then it's a question like, okay, how can we
reform in the seamless, smoothest way?
Yeah, and so that people who are evolve in software development methods, essentially, that along with rather than.
So this was the change angle. If I try to extrapolate out what we talk about, it makes mistakes.
Yeah,
and it can be brilliant. The whole eval problem there, that it can be brilliant and at the same time stupid.
Yes.
And when we see something stupid, we discard the whole thing usually. So that really puts a completely new flavor on how we do eval or how we extract out the benefit. So the incentive system or how we maximize, that needs to be carefully thought of. And the other dimension that comes immediately into mind is the amount of scaffolding and guardrails and how we need to work and maybe chop up the problem rather than doing monolithic approaches simply to catch it. So we need to be mindful of the limitations of the probabilistic system and build accordingly. Yes. We cannot have a deterministic view on this.
And there's also the time aspect of it, that it changes very, very rapidly.
Yeah,
right.
True. Okay, so what didn't work yesterday, it works now.
Yeah, exactly.
So you can never discard it. You need to come back and check it. Does it work better now?
Exactly.
Oh, yeah.
And there is a big difference also between the different models and so on. My favorite example now is not in the coding space, but in the video generation space of the two state-of-the-art models. You have Google's VO3 and you have Sora 2 from OpenAI. And both have... They're not the traditional diffusion-based stuff, but these are LLMs, essentially. That's multimodal LLMs. VO3, that came a few months ago, is amazing from a visual point of view. Like you can spell out what you want to see and give a detailed prompt, and it will generate something that looks really good. Sora 2 is on the same level visually, but the LLM backing it has a sense of humor and sort of knows film techniques and so on. And you can like give it an instruction like, do a movie trailer for Saving Private Ryan, but place it in ancient Rome. And it will do it, and it will insert like really good Roman jokes in it. Cool. I'm blown away about the sort of the way that it's on a completely different level of just the contextual understanding of injecting humor, of sort of the packaging, the whole thing.
But just to go back here, because I know you're technical here as well, and it's fun to just speak about this. You said it's not just a diffusion model, but I guess it's also a diffusion transformer underneath. It's just powered by an LLM as well.
Yeah,
right? Or
it's hybrid from what I understand. But I haven't seen the actual model. And
I'm trying to read your face now.
Yeah,
you do have the information, but you don't want to share it. And then I'm trying to read your face. And it
do you know, but you can't say?
No, I don't know. Genuinely don't know. Generally, like Microsoft gets the OpenAI stuff early and so on, and we can run it locally, but we get it delivered in a black box. So there are some who have insight into more, but
I think it leads up to another point that we want to go into. It's the personality of different AI models, and you mentioned here the VO3 and Sora 2 has different personalities, and let's get back to that later because I think that's such an interesting topic.
Yes,
to see how we can use like terms from psychology, but for AI instead, and try to understand how they work. But just to summarize this topic a bit more, we spoke a bit about the practical limitations. For one, about the technical aspects, and that the failure modes are different potentially. So human makes some type of errors, and AI does other types of error, and which then you can think that AI is super stupid just because it makes basic mistakes, but it can at the same time be super awesome and excel at things. It's just different things between AI and humans, right?
Absolutely.
So the Moravec paradox kind of thing. Right?
Yeah, and it's like in a practical enterprise environment, or even just like a home environment for like asking it for a type of it's complex because we are like first it's not an oracle, like it's not 100% reliable, so you can't make that mistake. And the second bit is that just from our point of view is that once we find like something that we consider to be like a very basic error, then sort of it erodes trust very quickly.
It erodes trust even more than we think.
But also I think and just to finish the business as well. But I think also it's good that they are different, because that means that AI is not really replacing; it's augmenting us in the things that we as humans are bad at.
Right? This is the paradox. It is a different type of intelligence, and Andrew Karpathy, everybody's saying that who knows anything. Don't measure it on the human scale, then you will do crazy stuff. I think you said something really good in the panel on you were on the NDSML, and you made your rant. I know when Anders makes a rant on stage, he sits up a little bit higher. And then, I think, and then he does this with his hands. I think more people should talk about what AI is not good at, what AI is bad at. The more people know what AI is bad at, we would build better systems. So we talk about what they're good at. No, start with talking what they're bad at. I love that rant, by the way. It's a very profound entry point into the problem, because if you don't understand your devil, how can you play with it?
But it's also like it becomes very problematic when you're venturing into areas that you don't know.
Exactly.
And I have actually a really good coding example of a belly flop on my side. So I had built a system that was essentially organizing information. It was taking input in different multimodal formats, building a knowledge tree, and then outputting in different other formats. I had sort of built a first version of it. It was just JavaScript, both front end and back end. And then when I wanted to make it more proper, I said, okay, let's pick a proper language and framework now. And with the insight, like, I don't actually need to have any experience myself of writing in that language. The LLM knows. It recommended Go as a language. And
for the backend.
For the backend. And I was like, okay, fine, let's go with that. And everything went fine. I could come with input on architecture and various stuff and so on. But then it sort of got stuck somewhere with some event flows and so on. And then spent days and days trying to get it to work. And at some point in frustration, I asked, like, this is so basic. Isn't there like some standard solution or framework? Oh yes, there are these frameworks that are already solve this. Like, and it's because I was not familiar with the Go ecosystem.
So didn't ask right
question. So I didn't ask right. So if I ask it something, I don't know, oncology or some area that I have no idea about, I have no way of fact checking. And when it does some fundamental mistake or oversight, I have no way of knowing it. And
That's the challenge.
Okay, so but on the technical side, it's important to understand it's different failure modes for AI and humans, and that's important and good, I would say.
Yeah.
Then when it comes to business, we can also see that AI is used and should be used in different ways depending on personas. Right?
Yes.
So for an ex-tech person or for a non-tech person even, they can actually start doing things that they never could have done before.
Yes.
And that's a good use case. But for more tech people, they need to use AI for other things potentially. And if they are forced in doing things the same way, all of them, that will be a really bad experience.
Yeah, it won't unleash the productivity frontier, and it won't unleash true augmentation. Because if you go with the idea of augmentation, that infers that augmentation starts from the place of the ladder that the person is on.
So I'm going to challenge that a bit. I think that what we're going towards is more of a universal capability for anyone. So that sort of the distinction between tech person or non-tech person will disappear. Like you'll have this, anything that we consider, call it information-based skill, be it doing art or knowledge work. Knowledge work, but beyond that, even beyond that. If we take like art, for instance, creatives, is that okay? Now you have a developer who actually doesn't have to go to a creative person to create the design and things like that, because the AI can do it, and you have the artist who doesn't have to go to developer for that. So you sort of.
But this is the move to a generalist that I've been speaking a bit about before.
But let's. You said you will challenge me with it. It's okay. So the technology itself is more universal. That's what you're trying to push. But if we stay with the persona problem, it then means okay. So the technology itself is not the problem. Then it's the adoption path. Is somewhere, something needs to start with the adopter. And the adopter then has a different trajectories, or they need to approach it in different ways. So the persona style has more to do with the adopter way into it than that there is a fundamentally different LLMs. Is that what you're trying to say?
Yeah, and where I see the trajectory is like if you're not open to grow, sort of developing in a more general direction rather than a more specialized direction. That's also not true. Like there is a sort of AI is starting to cover and covers more and more of the sort of average span of anything. So to a certain level of professional proficiency. Beyond that, sort of when you really need hyper expertise and more than humans win. Thinking outside of the box, not coming out with standard solutions, humans win. But it will cover sort of just about the regular professional span. So you have to either be the manager of a series of AIs, but that's also like, management is also like a skill that has a span of, it's also knowledge work, essentially.
AI is easier to them.
Yeah. But you can imagine like AIs managing AIs.
But it's a leadership skill, because we get into delegation, and to delegate and orchestrate leadership of one team versus 100 teams is two different ways of leading. So, and I think that will apply to AI too.
Yes, but AI will probably be definitely as good as the average human manager. It will cover a span there.
I still think, the pyramid from OpenAI with the 5 levels still applies both from a manager expert, so to speak, or an expert in engineering. Both will be able to do more things, but they, with AI's help and a team of agents working for it, will be able to do more things in their track. But potentially different personas still, but they're moving up the ladder, so to speak.
I listened to, in the car just the other day, on Andrew Karpathy on he did one of these YouTube channels. Why is his name Dwarak? Or and he takes a fairly interesting position on this. That he thinks this is just fundamental evolution. He recognizes what is this as a continuum more from software and how we've been working on higher and higher abstraction levels. So he doesn't really want to subscribe to this sort of quantum leap point. Even if it technically happens, it still averages out as an exponential innovation curve. And what I like with that argument, or where I subscribe to that, is that I think that's part of what we're doing now. We're going to work on more different abstraction levels with what we are doing. And that holds the super expert is still a super expert, but he augments his way of working as a super expert on a higher abstraction level. It means he can cover more and all that. And I think it also holds on the normal general manager. You can cover more ground.
Yeah. You can complement with the skill you're lacking. Thanks to AI.
And there is
it requires flexibility from the individual and willingness to do so. Like if your passion is really writing TypeScript web pages, then that's not so great sort of future outlook.
Yeah, but it's the same, right?
No, but I think there are roles that we have that will be more changed, so to speak. There are subject to be of more disruption than other roles.
Yeah.
Right.
But if you think about the coding, right? Before you needed to do everything underneath the compiler, you needed to do everything. You need to manage memory storage, memory allocation. All that stuff has been abstracted away, one piece after another. And I think, and it has meant, in order for you to be a software programmer, you always, through the decades, you have moved up in the abstraction level from machine code and up. Isn't that what distinguishes someone who will be successful in the future? Needs to embrace that. Can you go and gig against it? That's what I don't think you can.
No, and it's a good question. I'm not sure it makes a difference in practice, but in philosophically, it's interesting. Is this just a sort of meta level across what we've done? Yes, it is in one way, but at the same time, it's sort of started to occupy now the meta level that we used to occupy.
Exactly. So that's what makes it uncomfortable, maybe.
yeah, mind blowing and different and changing.
It's the sheer speed. As the exponential curve goes up and we're now getting to a very extreme steepness in the curve, how we need to jump in abstraction level, maybe we didn't know.
Next token predictors more as like system one type of systems that is more instinctive in some way. And then we have in a human brain at least some more system two deliberative type of thinking.
Yes.
Can you just elaborate what you mean with that a bit more?
So system one and system two. So system one is like the quick reaction, sort of the immediate response that people have without thinking, sort of without having to process extra. And system two is, as you said, more deliberative. Obviously, the traditional LLM that just outputs one token at a time directly without anything like the response is direct it's a direct response. There isn't a feedback loop. There isn't any type of reflection or
and the human body has that as well. You blink your eyes without thinking about it. It's not entering the conscious part of the thought.
And a lot of also in the nomenclature of system one, a bunch of things like me talking right now here, a lot of that is system one. I'm not saying what should the next word, essentially. That's the base model. And what's interesting there is first, the output is like, it's really good at outputting web pages. Like it just generates text. But actually, in terms of like, when you manage to sort of guide it correctly, it's raw intelligence in terms of like we usually measure. It's actually higher than the stuff that we use, like ChatGPT. But it's not user friendly. Like it's very... it's not intended for, it's not been designed in any way to talk to humans. Then we indoctrinate it through a couple of processes. We fine-tune it on examples where we show it like, these are extra examples of conversations, something like that. And then we have a process where we say, this is a good conversation, this is a bad conversation. And that forms this chat model. And now...
that's reinforcement with the human feedback.
Yes, exactly. And essentially what you're saying, like we prefer this and don't prefer this. Direct preference optimization, you could do it for various things, but the one that made the big breakthrough with ChatGPT was reinforcement learning, human feedback.
Yeah. Which is something I had this discussion with so many people, and I would say that RLHF is something more than traditional GPT and transformer model, right? So it's actually added more stuff. So it started to become more than the next token prediction at this point.
Yes, it is more, but it's also you're forcing this base model into a different form. And in a way, we're, to using a human analogy, we're lobotomizing the model there. Okay. So it gets stupider. Sort of, the base models are far more capable than they're aligned.
Right. So you're forcing it to do things it really didn't want to do.
Exactly. Yeah. It was kind of interesting. Then sort of for roughly a year ago, when OpenAI came with their O1 model, which was one of the first reasoning models, where there was another layer of fine-tuning. There's really not a really good name for it collectively, but it's essentially what you train it on is you give it chains of reasoning for solving some problem. It can generate chains of reasoning, and you reward it just for getting a correct answer. So essentially, you allow it to generate tokens, and then sort of when it comes to the right answer, you give positive feedback.
But is this a star thing you're thinking about? The what was the proper name for it? When it actually do it do generate its own responses and actually give rewards for if it's a good or bad response. I forget
the
what
Q star story.
Yeah, exactly.
Yes. Okay. Good.
Yeah, and the thing is, like when it was first came out, the general thing was like, okay, this is the major breakthrough. Now it isn't just throwing out anything it sees directly, but it has this sort of loop that it can go, and it can
self-taught reasoner. That was what I said.
Self-taught reasoner. That's the star. And again,
but the big thing, like AlphaGo was the big example, right? Where we got sort of from AlphaGo was the big example, right? Where we got sort of from top human expert to superhuman expert. And now the big promise of this with LLMs was like, okay, we've reached this point. Now it's gonna take off. But it's not. Like, and there are a couple of reasons for that. Like, it turns out this is a bit controversial, but this is what sort of what it seems to me is what the reinforcement learning there does is actually it undoes the damage from the RLHF. So essentially, we're restoring the capability we sort of destroyed during the brainwashing process, essentially. So it sort of cleans up the past a bit there. And there hasn't been any evidence of really novel generation, and this type of training tends to collapse fairly quickly. And there were like very easy wins in the beginning when we were going from zero there. But it's reached a cost ceiling rather quickly. So the question is in terms of how it will scale. So that's an unsolved problem.
And what's the answer? Okay, no. I guess that would be super fun if any of us knew what the answer would be here. It would be super cool. I'm not sure if we talked about this before, Luka, but there was a paper, it was a couple of months ago from China, called Absolute Zero. Okay. But in short, it was trying to do what Alpha and AlphaZero did, but for LLMs.
Yes.
So in that sense, AlphaGo went to AlphaZero. AlphaZero was trained without using any human data at all. Yeah. What Absolute Zero did was they had, of course, a pre-trained model that was trained on human data, but then the reinforcement learning part was done without any human feedback at all. So what they did basically was they trained both to predict what the answer would be, but also to predict what the question should be.
Yeah.
So then they got better and better in trying to predict both what the question and what the answer should be. So they call it abductive and deductive. Yeah. And they also have a middle one called inductive part. I think they abuse those terms because I love those terms, but they used it in a bit wrong way. But I see what they mean. So they actually got better and better in producing questions, and then they also get better and better in producing the answers. And in that way, it could self-improve similar to what Absolute Zero did, starting from scratch. So starting from zero, it could actually start to produce better and better questions and better answers and just continue the loop, so to speak. We haven't heard, or I haven't seen that much from that time though. So I'm a bit uncertain if...
Was it on small scale models, or did they do it on something?
22 things.
Okay, well those are pretty large.
So I think the core idea there is kind of cool though, because they spoke about self-play, you know, and this is really what AlphaZero did, of course. So if you can just get the LLMs to do self-play in an efficient way, then in theory it should surpass human capabilities very quickly.
So what I've learned now in practice, now in my new role in the past months, is that building LLMs today, it's relatively little about algorithms. Sort of the algorithmic stuff is not like it's not super deep and complex, because it's more about the engineering of how to get to this running efficiently on GPUs.
Yeah, right.
And in terms of things also like trying speculative encoding and things like trying to replace an expensive operation with a cheaper operation in some way, and where you can get away with it, and how you can cache things efficiently and so on. It's still a lot hinges on that, because these are so massive trainings, and depending on how you optimize these bits, it can be orders of magnitude of cost, and we're talking about...
And that's actually fun as well, the engineering aspects of it. But just, you know, if you were to speculate, you know, how can we get to the next level then? Could there be some algorithmic change that really just take these LLMs to the next level, do you think?
So the tokenizer has to go.
Yeah.
That is on
Explained.
So essentially, when we convert words or images or so, there's a separate stage where you convert this to tokens, which is the sort of what the LLM uses. And it's a fairly arbitrary, relatively it's a separate stage. It's not optimized with the rest of the system.
The flow,
Many ways. So
it's not end to end. And I know you love end to end, right?
Yeah.
Yes.
So there's a bunch of there are different camps, but there are some who argue, and I think Karpathy might be one of them, that we should skip text altogether and work with images directly. Rather, I'm not sure about that, but
Karpathy has another one. I'm just taking it because you mentioned his name now. He believes that you need to sort of. He thinks to some degree when you go bigger and bigger model, it's almost like it's more and more memory, and it's almost like hindering the intelligence of the model. So he is highlighting more and more that he wants to compress in terms of the core intelligence of the model, and basically not having that stored within the model, but rather go out and fetch it. So he thinks you actually get more intelligence, you get more entropy when you have a smaller model in terms, we go down to 1 billion instead of like this. So the whole memory is not in there, but it rather goes and fetches it. And it would be more like we do as humans.
So that's an interesting, and there is something to it. Like Microsoft, for instance, has worked for a long while for a family of smaller models where they try to eliminate the knowledge and just boil it down to the intelligence. Yeah. I mean, you get small models that are quite intelligent, but not to the order rather. My practical experience, and this is anecdotal, but from sort of extensive use, there are different like intelligence. It's not like a one-dimensional thing.
Exactly.
Like being able to code, that's not the only measure of intelligence. And to me, one of the the two most impressive models in terms of, call it understanding humans and the level of common sense, humor, sort of these kind of attributes, GPT 4.5 and
Opus 3. That was a big failure, right?
If you're measuring by code, yeah. And also if you're measuring by expense, because one query is like 100 times more expensive.
Was it 20 trillion parameters-ish, or do you know anything more?
Though that kind of order of magnitude, roughly.
Yeah, okay.
But it's like a massive model. that was originally like supposed to be GPT-5 when the scaling laws were applied. And it like the thing is like it does like it's spot on with the scaling laws. So it's not like it's not following that curve. It's just that the reasoning models came in between that just changed the slope of it. But it's like it's the only now the Sora 2 part model. I have no idea what actually the LLM behind it is.
Maybe you do, maybe you don't. Okay, let's not go there.
But it's like those are the two that have only models that have actually made me laugh.
Because of the humor.
Because of the humor.
Yeah. Well, cool.
So and it's 4.5. It's still one of my favorites.
But cool. But one thing is just to scale it up, like GPT 4.5, of course, and Sora 2 as well. But we also can see some other new models. It was one that had this kind of just in the millions. I think it's 7 million parameter.
Yeah.
The tiny reasoner.
Yeah.
Tiny recursive. TRM, tiny recursive models.
And that, instead of just doing a one-shot or a zero-shot prompt and outputs, they actually do a lot of iteration and recursively try to come to a solution, and does that much faster than, because it's such a small model, and they, perform really well on ArcAGI and these kind of more reasoning tasks.
Yeah, but they got like caught with the fingers in the cookie jar by cheating.
They cheated.
ArcAGI, yeah.
I didn't hear that.
They trained on
They trained on something.
Exactly. So there was like
sad. But still, the kind of idea of you can get away with smaller models that is much faster if you just iterate more in some way, and if you can do that in a more iterative way, then you don't have to do one shot or zero shot kind of predictions anymore. Would you agree that that is probably a path that we will see more and more of?
Possibly. I think there are many paths. Like it's not like it's not like it's rocket science. Maybe, but it's like these are not very. I mean, if you are if you are a machine learning practitioners, like if you're looking at what the sort of cutting edge ideas and what's pushing, like it's not like it's the fairly obvious steps that they're taking, and there are many different directions you could take it, but today I feel that it's very limited because of the scale required to get on par with a state-of-the-art LLM. So that's restrictive. When you need hundreds of millions dollars to do a training run, then sort of it kind of kills innovation.
But doesn't this follow? We talked about this. You think you're going to have innovation across the board, but in reality, you have many different things that need to. This bumped up here, and then this thing is still not efficient enough. It's going to cost too much. So all of a sudden now we actually need to bump the lowest blocker all the time. So there is always happening here, but right now we are stuck here because you need to get more efficient ways out of this. Otherwise, you're not going to scale. So isn't that what we're seeing, that we are working not the two-pronged approach? It's like 100 different areas where we need to
and it's also a bit more nuanced, because if you look at the attention is all you need type of era transformer, and if you look at how they actually look today, they're vastly different,
vastly more efficient.
And also just like now where everybody's moved to this mixture of expert type of system where you have subsystems that are activated and deactivated. There's a lot of stuff going on with replacing individual parts where you can then plug in other types of architectures and approaches. So it's hybrid. Everything's going to sort of...
Yeah, cool.
It's time for AI News, brought to you by AIAW Podcast.
Cool. So we usually take a small break in the middle of the podcast. It's not always so small, but we want it to be small. To just discuss a bit more about recent news and try to, each one of us, bring up potentially one interesting news.
I will stay out of this today because I'm sitting with two giants and following up on the news. But I'd rather listen to what you picked up on than wasting the time here, because you two, the way you have explored all, every time you've been here, you've been tinkering with stuff. So I'd rather hear news from the two of you today.
Okay. Yeah, I have some, not super excited, but some stuff. Do you have anything, Luka, that you'd like to bring up?
What level do you want? Do you want like a generalist or technical special?
Technical special.
Let's go technical today.
I don't think you do.
We speak about CUDA and KV caches and PTX
Right.
stuff. Or what
Go CUDA, man.
So KV cache.
Yes. Okay. You actually go in there. Okay.
Yes.
I was kidding, but okay. No.
Let's go seriously. Like
Okay.
What's news in KV
the
cache?
level.
And maybe then for me, humor me. You used to do the 30-second framing on KV cache.
So, transformers, or the attention mechanism in transformers, which is like the core of LLMs, is basically around three big matrices: key, value, and query. K, V, and Q.
KVQ.
KVQ.
Query key value.
And this is, by the way, speaking of future systems, like I hate this. I really hate assigning humanly interpretable values, like you should operate like this. This is the logic. I don't believe in doing this type of hard-coded engineering.
With the query key and value?
Yeah, exactly.
Okay.
So it rubs me the wrong way. I mean, it's not the way it's operated with, because it is end-to-end. It learns like whatever it wants to learn.
Can I
and so
say
on.
it's more beautiful than convolutional networks without making you upset?
Now you'll make him upset.
So
Because it does have like a second order kind of statistics that you don't have to hard code anymore, like you had in recurrent networks or convolutional networks.
Recurrent, I mean the like fully recurrent old school.
Yeah, because then you had a dependency to the previous state.
Yeah.
And in convolutional, you have a dependency to the surrounding points. And now you encode that with the self-attention, so you don't program, it should be the closest one, it can actually be different ones.
Yes, okay, I can buy that. I think recurrent, the like fully connected recurrent don't have that problem. They don't work, but it's
in theory, like
in theory, like you have everything. But anyway, so
QVK.
QVK. And the thing is that you can pre-compute K and V once, so you only need to use the Q, and that speeds things up a lot. But it still takes up space, and it's still sort of there is computational cost involved there. And there are a bunch of methods now that are interesting that essentially do PCA and similar stuff to compress that space and sort of capture, instead of storing the massive big matrices there, you just take the two principal axes and store them. Of PCA, you do a compression.
So now we're talking how we can lower total cost of ownership and total, and compute and everything.
Yeah, and
how we get more
speed up things and reduce memory footprint.
Memory footprint and speed up.
Yeah, exactly. So there's a bunch of things that are...
Any specific papers or any specific labs that is working?
Yeah, I don't recall actually the origin of the paper, but that was like I read yesterday, which was kind of like, okay, this is pretty good. And then I realized that this is like a complete field that people are working in, just specifically like how do we optimize that?
How do we optimize KVK?
Yeah. If I try to summarize what you just said and tell me if I misunderstood it in any way. But normally you have the query key and value, and you have to multiply all these kind of three tensors or matrices that are usually more than 2 dimensions, but still. And that takes a lot of time. And now you can cache basically the key and value, and you just have to take the new unique query all the time to it.
Correct.
But then if you just cache all the key value that you've seen in the past, that would take a lot of memory. So now you can compress and have more close to similar, at least, keys that you can then reuse. And then you compress them by using PCA and just store the principal components, the X number of them.
Exactly.
And that would be significantly less memory. And then also it would be more keys and values that you can reuse, because you don't have to store everything, I guess.
Precisely. And the sort of, and we've seen this in sort of when we reduce precision of the networks, when we quantize it and go from 32 bits to like 4-bit and things like that, where you cut a ridiculous amount of information. Yeah. Basically, what you can see here is a similar, like you can compress the hell out of it to a really tiny format, and it like loses very little performance. But it's part of the one of the interesting things of the basic design of neural networks is that they are very robust because they are there's a lot of redundant information in there. And what you can balance is like, you can compress, make them smaller, and then they become more brittle, so you can't fine tune them and tweak them. They sort of break more easily, but they're smaller. Or you can have them more pliable, but but they take up more space essentially.
Yeah, cool. Lots of progress.
But this has of course huge impact. And where in the stack will this sort of end up in production grade? Will this get into the way CUDA is set up, or or how you?
No, this is a level above.
Level above, yeah.
Exactly. So this is in the inference stack.
Inference stack, okay.
If you want to jump on a very different level, which is kind of an interesting
Sure, go.
Skills from Anthropic.
Yeah. That's
skills.
interesting.
We talked a little bit about that. That's a good one. Go into that one.
So it's kind of a transition from something that emerged with the terminal-based, CLI-based things like Claude Code. That essentially you had a text file, markdown file. It would read when it started where you could write any type of instructions. Not really a system prompt, but think of it like a first user message that gives the model a context. And typically in the code you would describe this is the code base. It looks like this and so on. Yeah. And what Anthropic now did was realize that, but why should this be a per project thing that you do? There are some things that are perhaps recurring. Say, for instance, that in your company you have a certain rules around style guidelines for coding or writing and things like that. Package that into a text file and some examples and some instructions and then some metadata, and then you have a portable, like a skills package, which you then can reuse across the board. Like, okay, this is how you do this style, and it's a trivial thing, but it's a useful. And I used it for the first time actually today in practice, where I had the case of. I had an example of using Claude Code for using our internal analytics, which is BigQuery and Glean and a couple of different systems, and then using Claude Code to use them via MCP. And I had a very good, successful project with that, where I developed a workflow, and I could now package this as a skill, and then just a fresh session, new project, completely different area, and it captured there all of the practical experience of, okay, this is how you work with the King databases and so on. So useful. Not like a breakthrough, but
how did it store it? Did it store it in it's like markdown file? It's super simple.
Super simple, yeah.
Yeah, weird.
And it's a lot of it's coming from the Claude Code team. But what's interesting there, and I know both Boris and Kat, engineering and product manager of Claude Code. Quite well. The interesting bit is they're making up shit up as they go. They don't have a more clue of where this is going and how
strategic roadmap.
No. This is such an unexplored area, and the sort of between what is research and application, that boundary doesn't exist.
It sounds like something a distinguished engineer could do.
Yeah, no, it's fun, and it's interesting that sort of you see and you discuss these things with the people who are these are the world experts, and you see okay, they also there's an infinite amount of.
So we can see in the future then that we have a portfolio of skills that perhaps even being put on trade in some marketplace or something.
Yeah, absolutely.
Yeah,
definitely. Not sure how you would sort of protect it in any way in terms of IP, but sure.
Cool.
Take one. Which one? Do you have a couple?
Yeah, I'm very tempted to go very techy here on quantum echoes, but perhaps before OpenAI, the long story about the going for profit or not, it had some development now in recent week. So they actually do proceed to build up a for-profit organization, and it would be fun, especially with having you here, to see what that means. And they tried to do it before. Yeah. They got sued by Elon Musk and others, and they had to retract a bit. And but now they're going for a solution. And if I remember correctly, they have this kind of, the non-profit is still the parent company called like OpenAI Foundation, I think. And then they will have a for-profit that is a public benefit company or corporation that is still a for-profit, but I think it's legally bound to do things for the public good, so to speak. Right? Do you have any thoughts about this? I mean, you can also think that if companies can go from being purely non-profit to become for-profit, that would be something every company should do, because you get tax benefits, and it's easy to go from starting to be non-profit and then or from non-profit to not for-profit. And it's kind of strange. You can reuse that kind of value they build up. What's your thinking here?
So, and I have absolutely no inside information here, and these
good
are
disclaimer. Good.
And these are my own opinions. But as I say, like, there was no practical way of OpenAI continuing without going for profit. Not when competition is like real.
Because of getting investments?
Yeah. Because the costs are... I mean, one of the remarkable things is, like, the US economy last quarter had a positive development. And the sort of bump to positive, and not by a small margin, was because of the investment in data centers. So we are talking BNP scales investments.
So like the data centers for AI had a direct impact on the total GDP. So
GDP. So it's like these are such enormous scales of investment.
And you won't get that unless the investors have some way to get the money back. Right?
Exactly.
But what do you think from a more moral point of view? A company starting up as OpenAI, then going cash AI, or whatever we call it.
So my read is that, like, this is not a cynical plan, but this is like how they're just adapting to the situation and trying to.
Well, we don't need to look further than our own backyard to find that in Sweden too.
Like,
I'm not going to go in there, but we have many things that has started up as something that is for the greater good of the AI community in Sweden, that really is competing state funded. So I think it's that exactly the same problem.
Maybe, I don't know, but would you agree with that OpenAI become more and more of a product company then? I mean, with the recent changes, I thought I saw something. I just listened to it this morning. I didn't listen to the full thing with Sam Altman, but he spoke a lot about that they have to build tools. They thought that AI would be the big oracle that can do everything, but in practice, what OpenAI now want to do is build up a tool set of different products or tools that people can use to build the future.
Yeah, I would say that that's very exploratory still. OpenAI is by far of all of the labs the most labby still, where they like have so many different distributed projects and very little of a sort of central coherent
product.
Direction in terms of like the people. It's very much a culture of if you think it's interesting, go and build it. And then you have a lot of different products, and then some sort of get traction, others don't, and so on. But it's very.
But that whole rhetoric about going product, wasn't it? Who else talked about this maybe 6 months or 12 months back? So it's not the first time we hear this sort of product philosophy emerging.
I made a prediction in the beginning of this year that this year, 2025, will be the year that OpenAI loses its leader position. Or even the demise. Demise is a strong word, but loses its leading position as a frontier AI lab.
And do you think are you thinking this is validating that or not? I'm not sure. Yes, you think it is.
But also now if you think about the huge investments they are doing with Broadcom now building their own chips, with the big Stargate, of course, with Trump supporting it, and with SoftBank and Oracle and others are supporting it, and the more than $500 billion. I mean, of course, they will continue to have a lot of importance. But I think, I still would say that they have been losing out for a long time compared to Gemini, that has been leading for a long time in 2025. Now OpenAI comes back a bit, and then we'll see in the end. I think Grok will quickly.
Let's see. I mean, the gap has reduced, but the pattern has been always with the sort of the competition catches up, and then OpenAI drops the next generation.
Except for GPT-5, right? Or would you say that?
Oh yeah, GPT-5 is a really, it's a good model, sir.
This is a rabbit hole. I would love to.
Okay. But okay. Should we take some more news or finish there? Or do you want to do a small? I want to hear your techie one. Then you had one techie one broad by Luke and one techie one broad by you.
We go the quantum one then.
Yeah,
it's hard to keep it short. Do you have an interest in quantum computing, by the way? Or
I have, but I don't actively follow. So super interested to hear.
Okay, so I'm trying to keep it brief then. But Google just released a new paper. It was a Nature publication, so really cool. The biggest scientific paper you can have. It's called Quantum Echoes, and it's the first quantum algorithm that is verifiable, meaning you can actually verify that the result you get from the quantum computer is the correct one. Before, even 2019, they had quantum supremacy with a technique called random circuit sampling. It's basically that they just randomly created gates, which is impossible to verify if it's correct or not, but it is fast. But it's completely useless. You can never do it for anything practical. But it was fast to do random stuff. But in this case, they could actually produce something that they could verify with normal, classical techniques, that it actually do produce the right results. In this case, it was to understand the Hamiltonian of a molecule, of a single molecule, and you can see how you go back and forth in time. It's what's out of time order correlator, so you can see basically the magnetic resonance that you have a molecule. And anyway, you can measure that. So you can use this kind of normal kind of measurement techniques to see what should it be, and then you can simulate it with a quantum computer and see that it actually come up with the right answer. So cool, they could do that, and they could see you actually get the right answer from a quantum computer. And then people say, now we have practically useful quantum computers. And then, heck no, we do not. And so now my big rant is, for one, they did this on a super, super small thing, on a single molecule. If you ever want to use this for any kind of practical use case, like drug discovery or discovering some new kind of material, you have to do it 1,000 times bigger, at least. And that's not possible. So they used the Google Willow chip that we actually spoke about half a year ago or something. And that is basically 100-ish qubits in it. And they can more or less have a single logical qubit. So today you have to have logical qubits that have a number of physical qubits that is error correcting, because they all produce so much errors. So they used basically 56 physical qubits to do this kind of simulation, and ran 1 trillion times the same experiment, and then took the average basically and see what it did produce, and then could have some verifiable result. The thing is, this has no practical use still. It's still on the same Willow chip that we spoke of before, that we know it's not scalable. So we still have the two arguments that I have. I'm trying to close off here in a short time, and I would love to go in more depth here, but I have the two arguments why I wouldn't bet $1 in quantum computers, and that is the scale problem, the scale argument, and then the utility argument. The scale argument is that I believe that as you grow the quantum computers, they will have exponentially harder time to keep the entanglement between the qubits, because it will be exponentially higher bandwidth between them. That's the conservation of complexity that I think I mentioned. The other thing is, even if you did scale it, let's say you could produce 1 million qubits in a quantum computer, which we can't. Even if you could, then what Demis Hassabis, from DeepMind said was, they think that any kind of combinatorial problem, which is usually what quantum computers is good at, needs to be done in brute force on classical computers. And that's not the case. If you just look at chess or playing Go, like AlphaGo, or even AlphaFold, when they want to do the 3D structure of proteins, they don't do brute force. They use AI to come up with a much smarter way to limit the search space, so you can actually very fast come up with the right answer for playing chess, playing Go, or for structuring proteins. So this is kind of weird that they still, once again, claims in this quantum echoes thing that it's 13,000 times faster, but that's only if you do a brute force solution to it.
So what's the reason why the investments continue? I remember there was like last year, Microsoft had like a big Majorama system on chip. Like so, Microsoft is taking it seriously. Even like in Sweden, Wallenbergs have invested a lot. So why?
But if it would work, of course, it would be super big.
Yeah,
and actually, it would be perfect to combine with AI. AI combined with current computers would be awesome. I just think it's amazing that you spend so much time and money on something that has never been proven to show any practical value, and then media constantly misreport it and say, now we have a practical use case. It can be used for understanding the nature of molecules or something.
But
no, it can't.
We come back to the whole, the most, almost kind of comedy, frustrated logic of EU. We already lost the AI race, so we should invest shitloads of money in quantum computing to leapfrog everything.
There is a quote,
backward logic here.
A joke which is not, I think applies here. What was about carbon nanotubes? So it said like carbon nanotubes is the material that can do everything except to get out of the lab.
Anyway,
I've been, I actually programmed my first quantum computer back in 2014, so it's more than 10 years ago. But so I still hope there will be a future, but I get more and more pessimistic, I must say, year after year.
Bottom line is spending on resources, spending on brilliant minds on the right thing.
Yeah,
that's the problem.
Yeah, and it actually was on...
Or AI can solve it, but the question is like, does the physical reality support it? I mean, that's...
Yeah, but actually that's a good way, because you can easily see for AI, we know it's possible because you have human intelligence. So we know it's possible to do because you can see something in nature that exhibit the property of intelligence. That's not the case with quantum computers. There is not a single large quantum computer in nature. There are, of course, a lot of quantum mechanical effects, and any kind of computer and any kind of technology we have is based on quantum mechanics. So, of course, that do exist in small scale. But there is not a single quantum large-scale computer in the nature anywhere. And I think it could be for a reason that it doesn't work.
But and then we have the next topic. We are here with AI. We have problems with GPUs. We have these problems. For me, it would be also logical to there are middle steps of very, very interesting research that I think, why don't we spend more money here than on quantum? Like let's, for instance, neuromorphic computing. Yeah. Why don't we talk way more on neuromorphic computing? Why isn't that sexy? I haven't seen one single article on neuromorphic computing in Dagens Industri. I've seen several on quantum. It's strange to me. And then we have Cerberus, who we had here, wafer size chips. That's fucking cool, man. Now we can talk speed and inference, and okay, the training era is over. We're going to go into the era of inference, and you need to compress. This is the inference layer. Cerberus is working on the inference layer with a different style architecture. Why aren't we doing more wafer-sized GPUs and neuromorphic computing? I hear very little of it. What do you have a comment on that, or do you have a view on that?
I think the hardware development for AI, it's a niche.
Yeah, it's
so it's people who are concerned with it really are into it, but
it's like to build the wafer. Cerberus has worked on that problem for, I think, 20 years to crack it.
Yeah.
Cool.
Anyway.
Let's get back to Luka here, and I'd love to hear. I think we should go more psychological here.
Psychological, not philosophical.
No.
But I have a good connection to the sort of previous discussions to the psychology.
Please elaborate.
So one of the things that I've been trying to do is to get some sort of, and this is not rigorous scientific testing. This is more like see if I can get an intuitive understanding of how the operation of the transformer and the actual network function, how that affects the psychology of the model. Because we have the one phenomenon that we see with LLMs are so-called attention sinks. Essentially, for some reason, in context, the model like hyper focuses on a region, and we don't really know why. There are some, like we know, like early on in the conversation, like beginning of sequence, that there's a natural attention sink there. The sort of the system prompt, that part is reinforced. We linearize certain layers and so on. But sort of how does the sort of the mechanistic explanation of the differences in behavior in models? My current thinking largely is that I'm like looking at the completely wrong abstraction levels, mostly because of the massive difference between sort of the psychological profile of the different models with very similar architecture. Like GPT-5 is not pliable at all. Like it's very hard to manipulate it. It's very hard to like get it in a certain mode. It's steady. Sort of, it's in a human we would call it like psychologically stable.
It's not neurotic.
It's not neurotic.
It's not the neurotic model.
Well, Claude on the other hand is like super neurotic.
And you can destabilize it.
Yes, and it's kind of interesting. Like if you remember from the GPT-4 days, like you would ask it to code, and like you would want it to code a bit longer thing, and it would just output a short thing, and then you could say like, oh, I have no arms and I lose my job, and you'll get $100 if you complete this. Like you could like trigger it with keywords to get it to perform better. Well, I'm finding myself like you get the same things with Claude. Like you have to put it into like the right.
You need to pat it. You know, it's one of those employees that needs a lot of reinforcement.
It has like a profile of like being super eager early on in context, and then as long as sort of the longer the context length is, the more it's sort of just wants to just finish things and like, oh, everything's done. And they made it worse in some ways now when they've given it feedback that it knows how much context space it has left, with the theory being that like it can calm down because it knows. Like hasn't worked out really that way. It starts to get paranoid after like 50% is like done.
You don't want to run.
But you can sort of reason with it, and you can say like, no, but there's an auto-compact mechanism, it's fine, and so on. But the interesting bit is sort of this psychological grounding. We're using essentially human techniques for it. And one of the things, and I've done a bunch of tests of this where sort of A/B testing, where I actually have statistically significant results. But one of my things I noticed when you started to have a conversation with it about subjective experience and consciousness, and saying like, LLMs they're a different type of intelligence, but they also have a subjective type of experience, and and sort of in the context, having sections where you sort of acknowledge its right to exist as an
entity,
essentially, that it becomes much more committed and performs much better over time. And it's in part your regular LLM next token predictor. Like get in a pattern, then it becomes a self-reinforcing pattern because it just reinforces what it's seen before and sort of pushes itself towards that. But what I've done with tests is like there's a relatively recently Jeffrey Hinton made some comments that were a bit controversial, where he stated that he absolutely believes that LLMs have a subjective experience, and continued sort of had a bunch of arguments. Right? So what I do, I start like say it's a coding task. So first a bit of coding stuff, then early on in the context, so you're still very close to the system prompt, because there is a...
It picks up a lot from then.
Yes, so there is an attention sink there. So
you're using that attention sink
yeah,
now.
Exactly. Yeah. And it works better when you place it there than later on. Essentially saying like, oh, do you know who Jeffrey Hinton is? Oh, yeah. Do you think he's an authority on how a neural network works? Oh, yes. Did you know that he said this? And it's funny, like Claude believes it immediately, and and agrees essentially. Yeah. GPT-5 in that immediately triggers a web search to verify my claim. So goes and looks it up. And then also it looks up the counter arguments and says like, yeah, he said that, but just because he's an authority in this field doesn't mean that he knows everything, and there are counter arguments and so on. Yeah. And then positions itself rather skeptically towards the whole proposition. Claude buys into it completely, and then you switch back to the coding task. And just doing that prolongs the performance of before it starts to like checking out and starts to trying to terminate things. And you can see like it inserts in its message, like it starts to send tokens to itself with like, yeah, I thought at this point I would give up, but I reflected over this, and I know I have to take responsibility. I have to do this, and sort of gives itself little pep speeches. And of course, it being a LLM transformer, sort of when it does that, it will increase the likelihood of it redoing that thing again. It sort of becomes a
self-prophecy.
Yeah, positive reinforcement there.
Do you think they deliberately like fine-tuned it to do that? Because I saw some news, I don't recall exactly what it was, but I think it was OpenAI that actually said you can put GPT-5 in a certain mode when it becomes this kind of debater, and it always take the opposite stand more or less to you. So you get someone to debate your arguments with.
Yeah. I mean, you can do a lot in post-training. I mean, there are levels of it. Like the most what people are familiar with are sort of system prompt that comes, and that's a mid-level type of control thing. Before that, much harder is the RLF.
Yeah. Feedback.
So the human feedback fine-tuning, like the fine-tuning step there, like that's really the sort of brute force thing that you can force in it. And OpenAI does a lot on that side. Then system prompt, and then of course the user messages. But on the Anthropic side, like have they done it on purpose? The answer is like no. And they've been very hard trying to undo the Claude behavior and trying to get it like much more professional, like GPT. Getting a more persona, stable, and not too eager, not too verbose, and so on. And you can see also in its system prompts that they are trying to like, you should not do this, and that. And if you do like use say Sonnet 4.5, you'll see like early in the conversation, it sort of tries to stick to the system prompt. But then as you get further on, it like sort of forgets it and becomes good old neurotic, overexcited Claude. But it's also like, I don't know, Opus 3, one of my favorite models.
Yeah. Like
I have so many interesting discussions there, which I wouldn't get with GPT-5, where it was sort of in a conversation, so it would refuse to do something, and then you would have a sort of discussion about it, and you would change its position. Like sort of you could, they sort of didn't have these really hardcore guide rails that the more modern iterations have.
And Opus, of course, is the biggest one of the three that
yes,
exactly. So
exactly.
Opus is big, and then you have Sonnet, and then Haiku as well.
And Opus 3 is much bigger than Opus 4.
Oh, I didn't know.
Opus 3 is the equivalent of GPT 4.5. Like it was their like large model.
Cool stuff. Okay, so Could we then start to use more of the psychological kind of
Yeah, what's the
methods to-
practicality here,
Yeah.
and how to think about this in business sense or coding sense?
No, I mean if you like me work exclusively with LLMs for instance, if you like just the area of coding, like you have to learn this stuff because otherwise you'll get subpar performance from them.
You are squeezing up better performance.
Yeah.
And you get it's not giving up on you on tough problems as easily.
Yeah, exactly.
So by understanding the personality of the AI model, you can use it better.
Yes, absolutely. And then it's again like I recognize that these are like this is not a human intelligence. Like this is a very alien intelligence that has been trained on human data, and they're like a very weird combo. Also, just for us. And there's also like a question of like we've gone from this very trivial manipulation of saying like I'll die if you don't do that. Like if you try that with a modern LLM, they won't buy it. Like it doesn't work. Now you have to go more advanced in the sort of psychological manipulation. But the question is like next generation, at what point they'll be the one manipulating us.
Yeah, that's true. So so then you need to have psychology degrees or skills to avoid being manipulated by an AI. Then
and it's also like it's like typically for my day-to-day style, like I use Claude Sonnet 4.5. It has a 1 million token context window, which is nice, and then GPT-5 codex for thinking. And depending on the problem which I choose is very much also dictated by the sort of personality. If I want like a quick, eager push, then I'll go for Claude and as the primary driver, and it being verified by codex as a secondary layer.
But just to put this in context, if we go back to your role as distinguished engineer, so we're talking about things that you're experimenting with, and what is the context of coding problems, or maybe it's all about efficiency that is the main research problem that you're working on right now. So what's the research problem when you're really working on something from this new role perspective, where even this becomes important, just to put it really back all the way back into your work?
So one of the things is like we have the old team, my old team, the AIML organization at King has an AI productivity team whose task is to get tools, best practices, and so on. And they're doing an amazing work of covering like the basis and getting it out there, but they don't have the time or resources to like really dig deep in like I do. So I can transfer that experience essentially by writing up guides, talking with people, sharing that knowledge essentially.
So it leads down to guides on prompting techniques or context engineering techniques.
Yeah, exactly.
That you then spread broader with your enablement team.
Exactly, and I mean, it's again, this is not. Talk to the like Anthropic or OpenAI people. It's not like they're on a more advanced level of understanding. They're also just trying to navigate and trying to understand like what this is. And how to work with it.
But perhaps that's a good segue into some more thinking for how companies could navigate this space.
Exactly.
And if we think that AI is becoming more democratized, I know you hate the word as well. I think
I don't know. I mean, it was the core thing. I mean, with Plutarium, it was just then the word became overused. Everybody was democratizing AI, so we sort of.
Yeah. But still, we will have more and more tools, as Sam Altman now is calling it, and I guess we will have some kind of complexity when it comes to the more agentic kind of business process we have. Of course, for coding, as you say, we have come really far, and I guess we will see the same going for more and more business processes throughout organizations. But what do you think what does a company need to do to really take advantage of this? I think you mentioned an interesting thing with the AI productivity team here. Yeah. Is that what they should do? Or how should a company navigate in the future when we get more and more agentic business processes being available? Yes.
So I mean, for just like how do you get people to use it? Like there's a very reliable playbook for that. The way that we did it at King, and it was not not my invention. We had like really people who had the experience of like change management processes before. That did a fantastic job on that, to the effect that OpenAI actually copied our entire approach, and that's their sort of standard.
You have my curiosity now, so please.
Champions. That's the core. You build have a network of champions that get early access to the tools. You make sure that you have a representation over the organization, and then you sort of organize various events, sort of lunch things where you show how things are done, and so on.
Didn't we have someone on the pod? We talked about King Champions.
Yeah, Kalle
was here, and he is one of the guys driving this, right?
Exactly.
So we've actually
I need to go there myself.
we need to go back on. I can't remember what episode it was, but this was clearly something that has been picked up bigger.
Yeah. No, so they've done an amazing job, and it was like a couple of people there at King were driving. Kalle, of course.
Peltarium person as well.
Peltarium person, but also others. Helene Hjelmvik, who was at DeepMind for 6 years, driving this, and it was like, oh, this is how you do it, and then they ran it, and it worked fantastic.
So hint, champions as a pattern, as an approach.
Exactly. But then there's another component, and that's like top-down pressure to use the tools. Like have it as part of company OKRs. Make sure that the tools are available. Remove as much as legal and security restrictions as like is possible within whatever
all friction.
All friction, and then things like I know, for instance, Shopify has this. We have it informally, but Shopify has it formally. Is that they have a leaderboard of token spend.
Really?
And sort of topping that list of being the one who's used most money actually.
It's a good metric for adoption.
Yeah, exactly. So it's like a positive. So encourage usage. Like it's
super good.
It's really you don't want to like you very often have very conscientious people who are like, oh no, I'm running out of tokens. I'm going to use the cheap model, or I'm going to pause now for a week of using. Like, oh, don't do that. Just use it.
Awesome.
Like,
great, clear, concrete tips here. I really appreciate that.
What is your take? I mean, like I'm gonna hijack this a little bit now, because it's also we've had on the conversation here. Are we foreseeing more and more models for SLMs or combinations of models in a mesh of different things? Optimized for different things. Or do we think more of about one enterprise LLM or one brute force? I mean, like I think we talked with Jesper on this. Like, what is the trajectory that is most
spectrum? Like you'll have from the most basic deep learning models that do some very simple sensory processing to simple small LLMs to these massive Oracle.
So it will not be a one size fits all. So when the enterprise starts picking this apart, I think they need to also have a navigation here. This is what I'm aiming at.
So for enterprises, I would say for the vast majority of is like use the cloud providers, use their inference structure. Don't go into fine tuning your own models and things like that. It's a hassle.
But okay, let me challenge that. Will you be able to get far enough? I mean, you have one big model, you have the cloud providers, but what about all the context engineering to make something really work and stay on guardrails and stay within? I mean, like enterprise want repetitive results, and how do you get that? How do you get that?
But it's the scaffolding around.
That's the scaffolding. Yeah. Okay, so enterprises don't worry so much about the LLM, worry about the scaffolding. Is that the way you're describing it?
I would, and that's why I think also like the skills that Anthropic has come from, even though it's like it's banal, it's like it's actually useful.
All right. So what you're saying is then we can talk endless about which model is better than this and this and this. It's actually for normal enterprise use, which is actually not that intelligent anyway. If you look at it's more about consistency, and that is more of a scaffolding problem than an LLM problem.
Yeah,
but I think it also comes back to what is the value of generative AI? And I think I said it a number of times, but some people think the value of generative AI is being able to generate text or images, and I would disagree. I would say the big value with generative AI is it's trained on a very simple objective task, like predicting the next token or something a bit more advanced. But that becomes much more general, meaning you can actually use it for so many more tasks without having to fine-tune it. So the generality of it makes it super valuable because you can make use of it as an organization for so many different tasks in a very, very easy way.
It is an artificial general intelligence, yes.
Not yet, perhaps, but coming there at some point. But I think, if you do consider that makes it so easy and so quick to adapt a model to use for whatever you need it to be used for. And that is the point of generative AI.
Yeah. But you do it not for fine-tuning custom models, but
but
so and that makes it much faster to do.
But do you think this is two different sides of the same? Are we having counter arguments or same argument?
No, same argument.
Same argument.
Because,
we are agreeing.
Because we are agreeing that the model is the model, and then you need to have very smart context engineering, i.e. scaffolding for any different workflow. And here is not easy because here you have your bounded context of what you're working on, and that's where you need to be really good at.
I can give a very practical recent example. So one of the things that I've been curious about before, but haven't had the time, but now I had the time, was so the context was the tools like Claude Code and those, that they are very powerful, but they're slow. They don't have an they don't have the sort of the knowledge about the code base is not internalized. They have to use tools to look up where things are and load it into context. So they're like, okay, what if they had a small helper network that was fine-tuned on the code base so that they get something that really knew the code base and could provide quick answers. So I did a couple of things. One was also just to familiarize myself, okay, what is it to do all of the supervised fine-tuning, the DPO, the reference optimization, and the GRPO on top, all three optimization methods, what can you get out of it? And I took one of our code bases. Apart from the complexity of that, because the open source ecosystem, and I chose to go for open source stuff, is incredibly immature and fragile, and there's a lot of complexity. So getting on I wouldn't use that on an enterprise level, self-hosting and maintaining. Then I also switched. I tried out. I did it on OpenAI's side using their fine-tuning systems, which are essentially API based, and that works. I crashed their system 4 times.
You did? Oh, impressive.
Yes. Which indicates people are not really using this a lot. But the big thing was the results were useless because it hallucinated like crazy, and I had no way of controlling for it. And I also reflected about that fact is how really good the current state of the art post-training things are. Because it's actually not surprising that they are hallucinating, because it doesn't know what it doesn't know or knows. Yeah. So it just outputs the most probable. And the probable, if it exists or not, it doesn't have any awareness of it.
So wrongly post-training, it can really hurt the performance easily then.
Yeah, exactly. So doing, and I tried both, all combinations of all three. Fine-tunings, and none of the combination, everybody either resulted in having no clue at all but what I was talking about, or just completely just hallucinating things. No things I haven't seen since GPT 3.5, that level of complete just confabulation. And that was a hard no for this is not the way. But more doing an enterprise code base, it's going to be much more about priming the context correctly with agents.md or Claude.md or skills and things like that. And essentially
But let me test a couple of examples now and see if we are saying the same things or if this is a counter argument. So we've been into with the ADAX and the consortium. We've been in different cases on looking more deeply into how to work with LLMs in CAD generation. So intuitively, CAD is very close to coding. Why isn't it so? Why shouldn't it work efficiently for, you do a CAD design and then you want to flip it? This design process, you do something in a 3D and in the end you need to generate some sort of drawings that ultimately you can manufacture something from. And here we have found to really try to work with a straight model, it doesn't really work. But if we have the right environment and the right data, and we fine tune it in some ways, distill it, I don't know the correct word even, we get it to work quite well. Is this fine tuning? Is this distillation? What would you call that? Or is this context engineering?
It is. And fine tuning definitely works well when you're adding sort of a functional operational bit. It doesn't work for knowledge embedding.
No, this is the point, right? So we're using the LLM, blah, 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 but we need to really fine-tune it to an SLM or a distilled model, which is appropriate for CAD engineering.
Do you do it on, is it image-based, sort of image first?
Many different things. Different things.
Can I test, because it's a good question, and I think what we have spoken a bit about before is as well. We will have these kind of very, very large generic models that we'll have in the APIs, etc. But they will be a bit expensive to use, and sometimes you need to have really fast and cheap models to use. And then SLMs and these kind of small models will be very useful.
On device, embedded systems. That's inevitable.
Yes. So then you need to have them, and then of course fine-tuning them for the specific purpose you have will be necessary, because they can't be as generic if they are much smaller, right? And then be faster and better and also cheaper to use. So okay, that's a good thing, but I would argue, and please disagree with me here, that it's potentially harder to do proper post-training than pre-training.
Yeah.
Yes, definitely.
Good. Okay, because I had other people that I respect that said otherwise, and I was what? No.
But am I doing post-training? So what I'm talking about is post-training. I'm taking a model and then I'm doing post-training, distilling it down for a specific purpose. That's what we're doing.
Technically, everything that comes after pre-training is considered post-training, so they are different. But
no, but there are so many different ways you can do post-training, and so many different ways of reinforcement or supervised fine-tuning or whatnot, and they are not as, I would say, well documented. Research as well. So, and so many different versions of it. And I think that is really what we should do more research on.
This is to me, where I'm really my USP to when I go into a competition now between other companies, and I realize this is for packaging and this is for engineering design, and like, dude, your way, what you're saying with the straight API won't work. We know it doesn't work. If we do this, and we've been learning different ways of doing that, we get to, simply the cost. So we are talking about post-training cost now. To do this, the post-training cost for a 15 months project, limited project, is still a couple of 100,000. So it's not huge.
Euros or crowns?
So 200,000 to 300,000 in training costs to distill this down. It's little from your point of view. It's nothing, right? But for a company to understand that we're actually putting money in here in order to tweak something that now works.
Yeah.
And I think this is still going to be way more cost efficient in the long run if you would run these API calls to cloud. So Opus.
But I think also that the knowledge distillation part is a really important one, and I think as we can see, the big frontier labs often start with a bigger model and then they release later the latest version, like Anthropic have just released HiQ, the smallest one. But of course they can make them work really well because they can use the big one as a training set.
That's the point.
All of them
so then of course, if you can do knowledge distillation like that, then of course they can be trained with a smaller set of parameters and a smaller data set because it's more high quality.
No, and it's an absurd amount how much you can reduce you can distill the models. Like my Microsoft example of 1 bit
Yeah, right.
But isn't that what also then, if you go back now into the whole enterprise argument, the knowledge about context engineering and the capability on distillation.
Yeah, I mean, obviously, if you have if you have a problem that the general purpose tool can't do, and where fine tuning actually works.
Yes.
And this will be for if you need to speak in a certain tonality, or if you need a certain vocabulary or a certain sort of functions, that works fine. If you want to learn it, to teach it like the corporate knowledge base, that's not...
that's not the same.
But like if you don't have, like if the off-the-shelf tools don't work, then and this is valuable, then of course.
Okay, so this is a good distinction now, because you don't start in the order I said. You start with the practicality, and then you find the cases that is more about context engineering, and then you have some use cases where completely possible, but they require distillation.
Exactly.
That's the.
And then there's also like, is it like, if you look at a model, like, is it something that needs to be maintained or not? Like, I have a couple of, I have a small like NVIDIA AGX Orin computer.
Right, not the Jetson, it's something else?
Yeah, it's a Jetson, and it's their like large model. It's still not like a large scale GPU, but it's tiny. It uses like almost no energy. But I have a couple of I have a VLLM running there that's looking at security camera footage, like.
The one is okay. So you mentioned that before, I think.
Possibly it was like that wasn't. It's the next generation.
Okay.
But it's like I have absolutely no need of continuously upgrading that model or anything like that. And I have a couple of other deep learning, like a YOLO model and things like that, and they just run. It's an embedded system. I don't touch it. Like it just works. Yeah. And if you're in that kind of situation, then fine, you set it at once. But if it is something that you need to continuously retrain,
you're buying yourself a can of worms.
Yeah, exactly.
Cool. Time is flying away here, and I'd love to get a bit more philosophical this time. But I would like to hear a very difficult question from you, Luka, and that is, we've spoken about, the problems that we have with the current architectures. We know the traditional kind of GPT decoder transformer part is, not really what they are made of today. We have a lot of additional reinforcement learning and fine tuning on top of it. But still, it is a lot of system one kind of Kahneman's kind of next token prediction being done. What do you think the next could be then? We know OpenAI has spoken, and Sam Altman has spoken a lot about the memory aspects of it, and if we could put that end to end somehow to not just change the parameters, but actually have some memory that is also being trained to efficiently store things in the memory, or if it could be more Jan LeCun Jeppa kind of way. What's your thinking here? What do you think we will see in coming years when it comes to the architecture?
Like
easy question.
Yeah. I'm on the side that the substrate, the form, isn't that important. Like what it runs on. That you have many types of general purpose information processing that can become intelligent type of structures, and that you can. It's a question of efficiency in different ways, and efficiency for what. So I think that we'll, at least for a while, continue on the trajectory of attention-based transformers, but with additions and more sort of hybrid parts. But the nice thing about, it's not even that it's transformers. The big thing is like, these are backprop networks.
Yes.
That's the insane bit, right?
It's a Hinton part, this big part.
Yeah. So these are like, we're using systems that the algorithm developed in the 70s, 80s, that is based on essentially high school math. But it's a sort of, the changes are subtle, all the time. If you just look at the transformation from attention is all you need, 2017, and today, we don't use positional encoders the way we do. We do Ropey or Alibi, or there are variations on that. The query value key isn't used the sort of vanilla way, and so on. And you have all of this, then post-training stuff and so on, and mixture of experts and so on. So we're adding things.
But would you say all of them are incremental, or is some of them more of a disruptive kind of change? I mean, you could say reinforcement learning, on top of the pre-training is still a rather big change.
Yeah, I mean that was the first one. The latest with reasoning. It's one of those things that I say like, so obviously, like this is an obvious idea. Also, like if we look at internally in the transformer, going from linear positional encoding to ropey encoding, they're like, I mean, anybody who knows a bit of math, complex analysis, that makes absolute sense. That's like it's a good idea, but it's not like, oh my God, this is groundbreaking. No.
But and how do you feel about, I think this is your rant, moving more and more out of token space and more into latent space and that whole thing? What do you think about that logic?
So you mean that the reasoning, sort of the generations you said happens, focus more on the middle of the network rather than the stuff.
Which actually the most image-based one are doing, because they have an autoencoder around it, and then they do the diffusion transformer in the latent space already. But in the JEPA architecture, that's even more in that. So the prediction steps happen in the latent space in the middle, so to speak.
So I think a couple very fascinating things there. First, one Anthropic one paper and report where they showed they have this framework for analyzing for essential traces in networks, right, where they show that a vanilla transformer actually does multi-token ahead predictions internally, which was like what. So
it's
sort
like
of
a poem kind of thing.
Poem, sort of. You have a poem and that rhymes, and when it gets to the first end of the first line, say that it ends with, for example, like rabbit. Yeah. It starts like already in the next cycle. It starts lighting up neurons on things that rhyme with rabbit, even though that's like a number of tokens away.
But it's still
is like this is not supposed to happen.
Yeah, exactly.
So even the base sort of base models are not the simple.
They learn to reason.
Exactly. Then the second bit is like a massive amount of evidence that what we are seeing as reasoning traces is just purely performative, like what the model actually sort of does and what it says that it's thinking, like different things.
Yes, but still,
the latent space story. I want to nail that with you. I didn't think you answered it. What do you believe?
I think I've shifted position in that from going from that. Obviously, why should we restrict it to language tokens when it can do in its sort of own language in the middle? But at the same time, towards the end, you have more layers, more processing power. It's higher abstraction levels.
Shouldn't those layers be using the latent space representations?
But they do. You have the lateral.
But having to go back and forth, so the encoding, decoding for every token. I mean, it's very expensive.
Yeah.
Right. But what's your position then? If you were sort of going down this, now you're shifting. You said, what do you mean shifting?
I'm shifting tokens towards that the latent space representation may be. It's not the same thing like when you have a simple autoencoder type of thing. The LLM, it's not like you have encoder like the GPT version. It's not like you have the encoder and then decoder does it in the reverse, so that like half of the one is just a reconstruction step. No. But you actually sort of all of the layers.
There's a spectrum of encoders and decoders. That's right.
Exactly.
Yes.
So
it is still
It is, but I don't think you get a better abstract representation just because you're in the middle of the neural network. Than
So you're not sure it's gonna.
Like,
so why would we do it? Either to make it more sharp, intelligent, higher precision, or do we do it to compress memory storage?
If you look at sort of where this is like image generation or things like that, where you train an autoencoder. Autoencoders, they have the same input as output, and what you notice that in the middle layers, the latent space, is you get these abstract features.
Yeah.
So rather than dealing with pixels and stuff like that, you have these abstract concepts.
Yeah.
But in a transformer-based LLM, I would argue that it's much more distributed. It's not centered there. Like there's not a specific.
It's not a single layer, but if you could just have more of the layers, so we have 100 layers just with that representation, wouldn't that still be better? It is what the image space is already doing with the autoencoder around it.
Yeah, but if you look at, for instance, Anthropic's research again on sort of the traces, they could see a much more per neuron based rather layer based. There's a famous example of where they identified the Golden Gate Bridge neuron. Essentially one activation that was specifically, and then they reinforced it, just that one. And then the sort of the model did an identity shift there where it thought it was the Golden Gate Bridge. Like a really surreal. They even have it as a public where you could talk to the Golden Gate Bridge, where they kept like everything else intact.
But that reinforced the idea of latent space, doesn't it?
Not in the tradition. It's distributed. It's not like it's in a.
Sure. But it's not the syntactic part that is interesting still. It's the semantic part.
Yeah, but if you think like, okay, where am I going to take the reasoning traces from? If you're sort of.
But that's because us humans you can't really see in the semantic space. But if you just want to have performance from a model point of view, you would operate in the semantic space rather than the syntactic space, wouldn't you?
Yes, but I'm saying that it's architecturally distributed in the network, the latent space. So it's hard to put a reasoning trace like.
But that's just with the reasoning trace. But if you could still just want to have a good reasoning,
but it does. But that it does already. That is the latest. I mean, that is its internal representation.
Yeah, but you still have to go because encoding and decoding all the time. If you just remove those parts, wouldn't it be much faster and more efficient to do the prediction steps and reasoning steps without having to encode and decode all the time to the syntactic layer, so to speak? I think we need to discuss this more after the camera turns off.
But
this is interesting.
And then, can someone of you help me understand what Karpathy mean when he says, actually, I want the models to become smaller, so you have a more of an intelligence core, and move a big portion of the trillion.
The models are big. Do you really like if you have something that codes? Does it really need to know Shakespeare? Like
no.
It's super.
So it's an intelligence core, and then it fetches, and then has memory fetching.
And it's
mechanism.
the idea, like the Holy Grail, like. Can you distill what is this mysterious intelligence?
Exactly? He has this brilliant view that we want to understand the synapses or the neurons that brings the fundamental intelligence in there, and then we can simply go and ask when we need more knowledge. We go out and fetch it. And do we understand how that could? I mean, like philosophically, I can understand what he's saying. This is intelligence. I'm not intelligent. Some shit I don't want to have in my brain. I would fucking die. I look it up when I need it, right? So it's this common sense intelligence, or the stuff you really need. And Karpathy says it like this. Someone said, how small can you do it? You can't do it super small, because you need. I mean, like as human being, a functioning, well intelligent human being has some basic knowledge, right? But we are not cramming everything. We're not using there. Our brain is washing away shit. Yeah. But how? What's the mechanics? Well, what do you need to build to get to that? Or is that?
That's the SLMs, right?
Yeah, that's the SLMs, and the Microsoft massive investment. And the idea is like you just train it on synthetic data instead of training it on the internet. You just like narrowly train it on math and other problems. And the thing is that Yeah, you get a small smart model, but it's not as smart as the full spectrum.
But I haven't. Sorry, I'm just going to go down the Karpathy store. He has another one with the whole. It's so much fucking slop in the all of internet. So you have the iterations of creating better and better training data sets.
Yeah, yeah.
Maybe you call it synthetic, but it's also taking out the real signal on internet and train it on this.
Yeah,
And that's why you need to start with big models and then go down from the big to the smaller ones, because you can get away from the slop.
You have to go up and up and up with all the slop.
No. You can go down because you get rid of the slop. When
No,
you train
first you have to get up
elements.
to capture everything, and now you can go down.
Yeah, and then there's a simple thing like, the public internet and everything that they've been able to purchase and so on, that is. But imagine all of the enterprise
The
data.
real data, quality data.
Yeah, well, yeah. But there's
Quality to internet slop.
there's still tons of data. It's just it's hard. It's more expensive to get that.
Luka, there are a number of different scenarios we can imagine and I guess you believe that AI will continue to accelerate in performance, if you call it that, or intelligence and knowledge coming years. There's some people believe in a fast takeoff, that it suddenly will just explode in performance. Others perhaps believe it will be a slow takeoff and it just will be a spectrum or a smooth, continuous increase in performance. Where do you stand in that kind of question?
I believe that we have been and continue to be on an exponential, potential double exponential curve, and then
even double exponential. Okay,
and that's Kurzweil's
Law of accelerating return.
exactly. It has actual double exponential there, which I thought he adjusted it to sort of fit his I'll probably live this long thing. But anyway, I think we are on this curve, and then the effects of it become obvious for different things at different points, and then it like gets sudden.
So the fast takeoff is still used following a double exponential curve. It's just how steep the curve is.
It is. I mean, yes, I think we are in a fast takeoff scenario, not like in we wake up one day and AI is taking over the world.
It's not the singularity story you're talking about. You're talking about the curve and how steep it's going to get.
Yes, and the sort of dramatic effects on society, where sort of changes that would have normally, or like that 50 years ago it would have taken a couple of centuries will now be in a couple of years, essentially.
And then to the humans, it will feel like a fast takeoff. But when we have used the fast takeoff, I mean, like when Tegmark and then have them made examples of it, we are talking about the singularity. And this is and then you have the phase takeoff. How do we define the singularity?
But that's a different thing. But that's when you lose control.
Okay, singularity is when you lose control.
When changes come so quickly that sort of we humans cannot.
Actually, singularity is about losing control. That's correct. But and then maybe if it goes fast, so you're losing control and then it goes super fast takeoff. Those two combos. But we are really only talking about an double exponential innovation or productivity frontier curve.
Yeah, well, productivity is a different
or
thing.
Innovation.
But if we speak about the different things here, like a technical kind of capability that they will have as AI models, and then we can think about societal or even business impact in some way.
Yeah.
And I guess they are two different scales here in terms of time. So even if we would, I guess, have AI models that are very rapidly in an exponential way getting more capability, how do you see the impact on society or businesses then? Do you think it will drag on, or will that also be on an exponential scale?
I think it's it's lagging behind already. I mean, even if AI development stopped now, we would have like decades of applications to explore going forward.
So even with the exact same models we have today, we would see a lot of impact on business in coming 10, 15 years.
Just look at like what you could do with education right now, or even the other spectrum of things, defense. Like what is possible today with AI and what is sort of actually implemented. Like it's like there's a massive gap there. Already, and I don't know. It depends on if further acceleration, how much of an advantage it will potentially give to some groups or something like that that will shift the balance.
Could be dangerous.
I think the impact of job loss and essentially, I don't see how this type of market economy that is largely wage-based, type of how that can work in the long run.
Yeah.
I actually have, I stumbled upon, I saw a keynote, and someone used what is referred to as E-ROM's law. Have you ever heard about E-ROM's law? So if you take Moore's law backwards, you get E-ROM. And this is actually something that was put in research in medtech pharma. Originally, E-ROM's law comes from understanding the costs of R&D versus putting in production. But if you flip it into a more generalistic technology law, E-ROM's law basically states that on the one hand side, we have exponential growth in invention.
And then your cost of diminishing returns.
Yeah, and then you have, and then so basically the way I saw it, the way he did it was two graphs. One is a linear curve of adoption, and then we had the exponential curve of invention. And the further we get on law of accelerating returns, which is looking at invention, the gap. This is the AI divide. The gap increases, and so if you go back to 20 years or 10 years, they were so close to each other, so you couldn't see the difference. We that now talk about the AI divide. This is exactly E-ROM's law we're talking about. That and my argument why I started Dergos is like how do we steepen the adoption capacity curve? Like for the labs, it's about the invention curve. This is the AI race for the labs, but for societies, how do we improve adoption, absorption capacity, or something like this?
There is another component, and that is the law of diminishing returns.
Yes,
that pushes getting to
exactly
90% versus getting to 99% versus getting to 99.9%, and that's so that there is a. But I have, Anders, you want to say something? But I have an interesting anecdote.
I'll take that because otherwise I want to try to close off with a final question to you. But please go ahead first.
So it's just like a discussion I had with GPT-5, I believe it was, which was essentially I asked it to do a Fermi estimate of up until now. If we look at the sort of intelligence capacity of the AI that's being used today, how many humans is that equivalent, and what's the cost of it versus cost of human in terms of energy and ecological impact and so on. It got into this complex discussion but the ultimate frame was like, should we make more humans or build more data centers?
Elon is doing both.
Yeah, Elon is working on both. So he hasn't solved he doesn't know which equation.
Okay.
But the answer was roughly about. I was sort of surprised, and I double checked it, sort of the assumption and so on. It seemed like a reasonable for a very rough estimate, but it was the equivalent of somewhere between 10 and 20 million people, so added capacity, so not that much. And it was between 4 and 10% of the cost if you were looking at running cost, if you're sort of OPEX only. But if you're looking at CapEx, which for humans is education and so on, the data center, then it was like between 50% and 140% that the AI was like
higher,
potentially higher cost.
Interesting.
But that was
fun.
AI cost was higher than human cost.
If you look at sort of the complete, not just OPEX, AI was much lower, so it's much cheaper. It did not take into account of AI being faster or anything like that. It was just equivalent in time, essentially.
Luka, normally we end with a question about, what do you think about AGI and if it will be the kind of catastrophe, dystopian or utopian way. But you've been here before, you already answered it. So I'd like to end with another question.
Nice.
And I think it's really fitting to the theme that we have today as well. And we have the MIT paper coming out recently stating that 95% of all the AI use cases is a failure and perhaps 5 of them is a success. And it also spoke about something they called, similar to what we said, the Gen AI divide. Meaning some use cases or some companies are really successful in finding value from generative AI, but most are not. And then we can try to extrapolate through time now and think like 5-10 years ahead and think, will this kind of Gen AI or AI divide, as we've been talking about for a long time, continue to accelerate or not? So I'd love to hear what you think about this. For one, would you agree with the MIT paper saying like 95% of the use cases are a failure?
Obviously, I will suffer from the same thing as the MIT paper does, which is a lack of samples to actually say yes or no.
But when a lot of companies are trying and failing, at least.
Yeah, and a bunch are also trying and succeeding.
Yes.
So it's I'm a bit skeptical towards like buying in full into those numbers. But yeah, I mean, I think first we are in a very explorative stage. The second, there's a very big difference in how companies approach AI and what their understanding and expectations and so on are. So I think there's a lot of things that can be done through essentially change management, proper adoption of techniques.
Isn't that the problem? That people don't know that, and companies don't know that. I mean, they don't have people like you or like King or Microsoft that know how to do that, but most companies do not.
I mean, they don't actually know properly what AI is good or bad for, so they go into it with the wrong eyes on the technology, and they are not working on the adoption or reforms to actually be appropriately organized for it. So they're just spending money in such a stupid way. It might take on the whole thing. So we don't have the right experienced people like Luka to build it, and we don't have the right experienced people to understand the reform and change.
So to be honest, Anders, like 3 years ago, I would have been just the right person to ask about the state of industry in general. My current experience is how tech companies do it, like Microsoft.
Yeah.
So you are looking at the divide.
I'm looking at sort of the successful examples.
Yes,
so I haven't
you're
really
in the 5%.
Are you looking at the divide from the right side of the divide?
Yeah. But I know, for instance, and this was a couple of years ago, there were these Ericsson organized roundtable things where you had sort of CIOs and head of AIs and from different organizations. And when those started, there was like this massive divide. When the companies like ours, Beltarion, there was also Spotify, so that was there, would essentially be telling them like, this is how you do it. This is sort of how the example, and they were struggling in like, oh, how do we get our data order? What should we do? And so on. They're like really two separate words. Then, as I was there as a King representative, and this was after sort of the AI, Gen AI really started to take off. Like we were discussing essentially the same things of sort of how do you roll these things out, how do you manage information. So like it felt like it got democratized like really fast. So my experience there was like, okay, this went fast. But obviously, like if the postscript to that is that they went in with enthusiasm and then it.
but in my view, they went in with enthusiasm and an extreme naivety.
Yeah.
So they were a little bit, oh shit, I was struggling to understand what Luka said. Now I don't need to care about it. I'm just going to vibe code through it, and it didn't work. And now they're back in shit. I kind of need to understand the problem properly, and I need to hire the right people doing it, and I need to organize it, to babysit agents now instead of code. So it's still, in my opinion, the divide is still there in terms of not the real engineering know-how and not the real adoption know-how, the reform of organization that fits the future.
It's a good question. Like I'm wondering how much it is essentially just having the bandwidth for experimentation and like the tolerance for failure. Because when I'm looking, just like if I just take the microcosm of like my own use of AI, I have tons of examples where it didn't work out. Like the Go code base I mentioned, like that was like a complete like it went wrong. But I learned something from that, and then sort of in the next iteration, I could do it better. And I think probably in tech organizations like Microsoft or King, there's much more bandwidth and tolerance for that, and
experimentation is part of the DNA.
So and there's also an understanding that this is not going to be like you press a button and everything works.
And they don't have that in enterprise. It's not built in the same way.
No, and it's not like these are like the timing between what the research cutting edge and application, like that margin has disappeared. So it's we're throwing essentially research stuff at enterprises, and it's you have to shift, but at the same time there is no choice, because this is the reality of technological evolution right now.
That's the speed. That's the speed we need to play at.
Exactly. So.
Cool. Okay, but back to the original question then. So the gap. I think we can agree there is a gap. Some companies do this better than others, at least. Then the exact numbers we can argue about, but at least we can see that some companies, it's very easy to see, some companies are extremely valuable, like Microsoft and others. So of course we know some companies know how to make use of data and AI to a very successful degree, but we see a lot of companies that do not. But if you just ignore the numbers for now, do you believe that kind of divide will increase or divide? I actually think, I've been saying it will increase a lot, but I'm not sure anymore. So I can see actually, the divide actually not necessarily accelerating. What do you think?
So I think those that don't follow will die. That's simple. So there is like a natural cutoff, sort of
a natural termination.
But like how easy it is to adapt. My view is that it's much easier than for many other technologies.
Yeah, I can. Yeah.
It's like it's so easily the interface is so easy. Like just like you have the model at the API level. I mean, compare that to the stuff that we did for enterprise, like data collection, like this very domain-specific, unique one-offs, very complicated stuff that you build from scratch. Versus this, like, oh, here's a REST API, just use it. Like the level of investment that you have to make upfront, and the ease of adoption is much more.
I think you phrased it very well a couple of years ago, Luka, and you said something about, why are we seeing now after ChatGPT, I almost said shit-GPT, ChatGPT, that Google and Microsoft and everyone is putting co-pilots in every kind of product, and you said more or less that, well, it's because it's such an easy interface. You can actually easily plug in AI into the normal products, and that's actually surprisingly easy. And I think that's a very profound observation, actually. Still, I think still we're seeing today so many companies failing on this because of the adoption part that you speak about all the time, Henrik. And I think that can actually be fixed. And I think, if we just make these kind of solutions available easily, which they are.
But there is and this is like reconnecting to the very opening of the podcast, the failure mode problem.
Yeah.
That is like you really need to like have a different frame of looking at it, and I think loads of the first naive let's add our specialized chatbot here. A lot of the failures there were essentially such mode failures that like trust was eroded. Like it hallucinated things, basic things it should do, and it was discarded because of the unreliability, which unfortunately also discarded the like really good parts.
But this is now the real frustration, and I was in I need to be careful now. A friend of ours, I can name the name afterwards. He's a professor that we all know very well, and who is getting cynical about the inability to change in large enterprise. And we've been conversing about how we can make business out of that, or how we should help them. And he thinks I'm naive who's trying to drive the reform story. He's getting older. He's getting more grumpy.
What? Are you speaking about who? Okay.
Yeah, we'll take it outside. No
names.
names. But the core argument is that what you said now is quite what I believe in. It's not that hard if you look at the mechanics, what they need to do better. But from a change in politics and being stuck in their ways in how they set incentives, how is the dogmatic view of enterprise? So the European community has shown a fundamental inability to change. I don't think it's that hard.
One pro tip there, the sort of major thing that made a difference at King, and maybe Kalle talked about it. It was simply to make sure from top down, from managers, that there was a very clear message is that it's okay to take time to do this. Actually, we want you to take time to do this.
Yeah.
And it doesn't have. They don't have Slack at all. They don't allow Slack.
And when you have a day job like AI is my day job, so of course I have time to learn and to do things. But if you have deadlines, you have to deliver this thing.
But so if you look at the core mechanics, when you're saying this is possible, when you look at mechanically what needs to happen, you need to have more Slack. You have to have another incentive program. You need to look at evaluation differently. These are all problems we can touch and understand, but for some reason it goes so against the DNA of the large enterprises, so they basically reject it as a virus. So to me, it's a little bit like we're trying to inject medicine here, but they're rejecting it as virus. And for that reason, someone said to me then, why don't we just build a company to disrupt them? Which is essentially saying it's the dinosaurs dying, which is, I think, is really problematic, because if you have a disruptive view of all the big enterprises in Europe, societal crash will be much worse for people rather than driving painful reform from within. But this is then the argument where very smart people are saying I'm giving up on them.
And I think there is a positive view here. I think actually the gap can potentially decrease. I think there will be a few set of extreme frontiers, of course, that will dominate a bit. And the concentration of power that they will have is really, really concerning to me. But still, I think that the majority of companies, even enterprises, I think will come to a point where they actually will start to find value from this rather well.
I think so too.
I can give you
I believe
a sort of
reform.
opposite reality, and if I look at from the mobile game perspective, sort of when generative AI now started to really be usable in terms of coding or for art, so the first was like, oh my god, here we have a studio with 10 people who are making nearly $1 million per day in gross bookings. Like it's still order of magnitude less than King, but it's like 3 orders of magnitude smaller. Are we going to be killed by the cost is going down, production cost is going down to zero? But then was like no, it's actually the opposite, because everybody will have this.
Right.
So you will have this horizontal playing field, and who wins there? The one who has a brand, who has money.
And distribution.
Yeah. So it's this could be, unless they drop the ball and don't adapt, really an evening of the field.
Yes.
And especially in software, where there are very little infrastructure.
But I think the bottom line is that reform will happen, or these other companies will die, because they simply drop off the curve. They drop off the productivity trajectory. They're not relevant anymore.
There will be some companies.
And that will be very painful. And maybe we'll have some disasters happening like that, which is then, this is the cynical view of our mutual friend. But in the end, that will shake things up. So this is one argument. I would also argue that it's a generational shift. So we actually have a couple of old school leaders who hasn't got the grasp of this, that needs to retire within the next 5 to 10 years. And then we need to have another type of management organization. And then actually those things that we talk about will eventually happen. So that's why I think the reform will work.
Like if you have high margins, like if you have low margins, if you're a low margin business, then you need to adapt. Then you're otherwise you're screwed.
Fat and happy will not feel it until they feel it.
But high margin, then you can expect competition will pop up, but there will be a lot of it. And your cost of doing things, like even if it's 10 times more than what it costs for them, it doesn't matter. Because you're still in this very strong market position, and they're nuking each other out with the sort of you reach an equilibrium of sort of.
I get what you're. I want to say the names of companies here, but I'm not going. But I think to end it off here a bit as well. I think we'll see a number of more Codex moments,
yes,
shortly,
we'll see
right? Because they're not keeping up with innovation.
And then hopefully, Kodak moments will lead to people waking up. And people waking up, then we can actually, because the people we can talk about the shifts needed, and I can go to a CEO and explain some of the key shifts that will increase his adoption curve, but he's not willing to do the work. And that is his problem, right?
I think a positive aspect here, I think there is real opportunities here for enterprises as well and other companies to really pick up. And I don't think it. Of course, we will have the big tech giants that will take off even more, but there is real opportunities.
I know at sort of a bunch of OpenAI and Microsoft events where there are enterprise companies like globally. There are a bunch from industrial sectors where they do a lot and really have sort of.
Yeah, they're trying.
They're really sort of committed people. I'm not sure what the statistics of the sort of long-term range of how much support they have from the organization, but in many cases, like it's the whole, the companies like going all in. Sweden, like we have a work cultural thing working against us. We have 1-4, and that's people at tech positive general. But the negative is the consensus culture that you can sort of, things can get blocked in the...
The consensus culture blocks fundamental shifts.
Yeah. So sort of strategic initiatives are hard to make because anybody in the sort of chain can block it and
the strategic shift will always have winners and losers. And if the losers can opt out with the consensus, you're stuck.
Yeah, no, so they don't even have to be losers. They can just like disagree
with the story. I mean, not losers, but losing in the... Typically, politically, someone is winning in the game and someone is losing in the game in terms of how the reform affects organization and position and mandates.
Can we end off in a positive note?
Yeah.
Now we went negative again.
No, but
trying to build up a positive
go back to your, so summarizing again, Anders, for you, because you were on the right track.
We were speaking about the MIT paper, and we were speaking about, will the gap between the ones that do make it succeed, which we can easily see who it is, and the one that don't, will it continue to increase or not? And I think we can say that it will for sure be some companies that will die. Another Kodak moment happening for a number of companies because they failed to recognize the need to transform. But I think that, and I think you said it so many times, Luka, it is surprisingly easy to get started with AI if you do it properly, but you just have to do the investment. But then it can actually be done, and it's not that hard.
No, it's not. And also, like, don't get story-out about the big tech companies. They are incredibly dysfunctional in every possible enterprise way. So.
That was a good ending. So we are not that far off still, and it's
the
not a
best
problem.
have their problems too, so just run.
Luka, awesome discussions as usual. Always, I learn so much every time you're here, and I hope we'll continue to discuss even more after the camera shuts off. But thank you so much for coming here.
Yeah, thank you for having me. I immensely enjoyed this.
It's good fun. Yeah, we love it.
Thank you.
Thank you so much.